Hi everyone, welcome back to our YouTube channel Electro Study. This is lecture series 16 under computer networks dealing with virtual circuit approach. Come let's go into the video. Please do like, share, subscribe and comment. In the last video, we have seen about the datagram approach. So here datagram approach and virtual circuit approach is nothing but it is a division that comes under packet switching. Datagram approach, we saw that it is connectionless services. Here, virtual circuit approach is connection oriented services. That is, it is a network where virtual connection is established between the source and the destination. So, through this network, the packets are transferred during a call. The path is established between the 2 points and it appears as a dedicated link. It is appearing as a dedicated physical link. So it is called as, only because of that, it is called as virtual circuit approach. You can see the pictorial representation of this circuit. See here, from network layer, the data is transferred from a client side to the server side. So first, the client side is initiating a call. So now once the call is initiated, there is an incoming call at the server side. The server accepts the incoming call. After accepting the incoming call, the call is connected by the client side and it communicates each other with a secret code, and the data is being data starts to flow from the client side, and when it starts flowing from the client side, it reaches to the destination, and the particular data is received by the server. So see here, there is a graph that is represented for this circuit. See what happens is, step 1, the sender A the sender A is establishing a call request connection to connect the receiver. So it is sending a call request. After sending the call request, what is the next step is, the receiver B is establishing a call accepting. The receiver is accepting that call to connect with the sender. Now what happens is, the data will be transferred whenever the router is established. See, these are the routers that is placed in between the two ends. Whenever it is established, the data gets transferred. Now the node 1 and node 2 are the intermediate nodes between the sender and the receiver. So the data will be transferred by connecting two nodes virtually. After transmitting a data, an acknowledgement signal will be sent by the receiver by saying that the message is being received or the data is being transferred. After sending that, there is a clear signal which will be sent if the user wants to terminate the connection. So suppose there will be two steps that is occurring. After a positive feedback from the receiver, the call will be still continuing if there is no clear message passed on. It will again give a request, it will accept the call, data gets transferred and keeps on doing the same until a clear message is sent so that the connection is abruptly stopped. So this is the virtual circuit approach. Under virtual circuit approach, you have three phases. One is setup phase, data transfer phase and tear down phase. So under setup transfer phase only, you have two requests that is produced by the packet. One is, you will be requesting the data, that is the server will be requesting the data, and another one is the server will be giving an acknowledgement request to the client that the data has been received. So those two phases will come under setup phase. So we'll be seeing these three phases in detail now. In setup phase, you have a sender A and a receiver B, and you have pockets in the form, and there is a switches connected in between rather than routers. Now you have particular table where the port number is mentioned, and there is a label called as VCI. VCI is nothing but virtual circuit identifier. It is nothing but it is representing the label of the data that has been transferred. So here in setup phase, what happens is the router will create an entry for the virtual circuit. Say for example, suppose this source A needs to create a virtual circuit to the destination B. Two auxiliary pockets need to be exchanged between the server and the receiver. Okay. Now the request pocket and the acknowledgement pocket will start functioning. That is here. Now a pocket is sent through a switch 1. Now the receiving switch is nothing but the switch 3. Now it is passing through switch 2 and it is reaching the destination. We have to mention from which port it is communicated. So the incoming port will be 1, outgoing port will be 3. So for incoming port, you will be having a label along with the data. That label has to be specified, and this outgoing label is not known because we have not reached the sender. The acknowledgement is not received from the receiver. So this outgoing virtual circuit identifier remains unfilled. When it gets filled is during acknowledgement phase. So what happens is now the port number and the incoming port was mentioned for each and every nodes, and after that during acknowledgement phase, after all the data is sent through the receiver sent to the receiver end, that is destination end. Now the destination end will send an acknowledgement back to the sender. So during that acknowledgement you will come to know what is the outgoing port communicated. So this will be your outgoing port from receiver you are sending into sender. So this will be the outgoing port, this will be the incoming port, and you will be filling this outgoing port. This is 77, this is 22, this is 66. So completely your table is now filled. Got it? Now under data transfer phase, what happens is this will be your second phase. After all the routers have created their forwarding table for a specific virtual circuit, the network layer pockets, what it does is that is belonging to one message can be sent one to the another. That is, see here, now it is having a data. What is the label mentioned here? 14. So with this label attaching the data, it is sending to the receiver end. So the data transfer takes place here. Already this lookup table or the forwarding table is filled in the acknowledgement phase. After that, it will identify the port number and also the label number. Along with the label number, the data is sent, so that the complete circuit will understand that seeing the lookup table only, it will understand from where the data is originated and which port it is communicating. Now next is tear down phase. Tear down phase is nothing but after the complete communication has taken place between a sender and a receiver, there is a special pocket formed. That pocket is called as tear down pocket. So that is nothing but that happens in the tear down phase. It is telling that the complete communication is done, and now I am raising a special pocket to notify the receiver or the sender that the complete communication is now done. So this is what it describes the complete diagram of what is happening in the virtual circuit approach. See, there is host. In between the host connection, there is switches to connect. Then first circuit is established, and there is a transmission that is happening between host 1 and host 2, and now here the delay between the transmission at different slots is measured, and from this transmission delay you are calculating the propagational delay from host 1 to host 2 through different switches. After that, there is a information transfer, that is data transfer. A particular time will be given for that, and then what happens is there is a special pocket that is formed from the host 1 and it is sent to host 2 to tell that the complete packet is being sent to the destination end. Got it? Is it clear? Now we'll be seeing about the difference between what is circuit switching and packet switching. So circuit switching, we tell it as it is connection oriented service. Packet switching, it is said as connectionless oriented service. Now under connection oriented service, the entire message should follow the same routers for transmitting the data. In connectionless service, It is not that the entire message has to follow the same path. It can be divided into different paths independently. And generally, circuit switching occurs in physical layer and packet switching occurs in network layer. In physical layer, as we are using bit streams, or waves, such kind of inputs, there is no wastage of bandwidth. It is idle. And here also there is no waste of bandwidth if it is idle. If here the bit streams are idle, then there will be a waste of bandwidth because waves will be formed, so that bandwidth will become waste. And there is an initially it was this circuit switching was initially designed for an voice transmission, but packet switching from the first, it was used for only data transmission through switches or routers. So if it is a physical link, there will be a probably complete link will be formed between different routers. User can see the link that is formed. But when it is a virtual circuit, it is virtually forming the layer, because even if it is a shorter path, to find the shortest path, it will virtually form a circuit, and then it will decide what is the shortest path and it will form a physical link. Hope you have understood about this virtual circuit approach. Thank you. Stay tuned for more information.